Consider in what way you know how strong concrete is. Stretch it, punch it, use a hammer. Well, this may work, but it doesn't give you any hard data. What we need is this, an instrument. This machine measures the compressive and splitting tensile strengths of concrete, which are the ultimate force that a concrete can take. In other words, how strong it is. Strength is the most valuable property because it gives an overall picture of the concrete quality. Strength is directly related to composite structure of the hydrated cement paste and aggregates. It is getting harder and harder because solid structure grows with time. Also, strength for concrete is a vital parameter of structural design and data required for in situ compliance test. Concrete tested with compressive and splitting tensile strengths can be acquired by two means: in situ coring of hardened concrete cylinder and direct casting of fresh concrete into standard cube and cylinder molds. For conducting either a compressive or a splitting tensile strength test, you will need only 4 tools: a caliper, a moist cloth, and a compression testing machine, and auxiliary platens. For compressive strength test, there are 3 steps which must be followed strictly to perform the test. The first step is specimen preparation and positioning. The second step is loading. The last step is assessment of type of failure. The tested specimens can be either cubes or cylinders. Cubes are sized 100 mm or 150 mm, while cylinders can be of 2 sizes. The first is 150 mm diameter, 300 mm long, and the second is 100 mm diameter, 200 mm long. Damaged specimens or specimens which are badly honeycombed should not be tested. Watch carefully now as drones perform each step. 1. The first step is the specimen preparation and positioning. A. Wipe the excessive moisture from the specimen's surface. B. For the test using cylinder, cap the surface of the cylinder to flatten the contact surface. Let the cylinder cool down overnight until the test is carried out on the next day. If the surface is not flat, it may result in stress concentration, which can initiate early failure, resulting in a lower crushing strength. C. For the test using cylinder, use a caliper to measure and record the diameter and length measured to within plus or minus 0.5%. D. For the test using cube, use a caliper to measure and record the length, width, and thickness measured to within plus or minus 0.5%. E. Wipe all testing machine bearing surfaces clean. F. Position the cube or cylinder specimens that the load is applied perpendicularly. And G. If auxiliary platens are used, align the platens with the top and bottom face of the specimen. Also, there are some other requirements about shape, dimension, flatness, perpendicularity, and straightness of specimens specified in standards, but these requirements will be left for the reader's interest. 2. The second step is loading. H. Select a constant rate of loading within the range 0.2 megapascals per second to 1 megapascal per second for compressive strength test. Apply the load to the specimen without shock and increase continuously until no greater load can be sustained. I. Record the maximum load indicated. 3. The last step is assessment of type of failure. J. Observe the failure type of the cube and cylinder. K. If all 4 exposed faces are cracked approximately equally, generally with little damage to faces in contact with the platens, the failure is satisfactory. L. If cracks happen unevenly at the exposed faces, the failure is not satisfactory. Record the failure mode. It indicates a probable fault in platens or in the testing machine. Watch while these steps are repeated. See if you can follow the steps.